You are welcome once again to my channel. So in this video we're going to look at Schneider soft starter. So we're going to look at the application of Schneider soft starter, where it is being used and why it is being used. We have looked at ABB soft starter is in one of my previous videos, so you can still go through it. But this is Schneider soft starter. It looks so simple and is widely applied and is very useful in the industry. So that's why I want to make a video on it. So you have to pay attention as I'll be showing you the connection, the schematic diagram, the connections, how it is being connected. Alright, so this is a Schneider soft starter. We have three potentiometer. We have the start that controls the start time, initial voltage, and stop voltage. The start time, is the time or duration from which the initial voltage rises to the supply voltage. That is our full voltage. The supply voltage is our full voltage. So whenever you power the soft starter on, this green light comes on, and when it has attained the full voltage, this yellow light comes on. So this is our initial voltage, and it will take the time you set here for it to rise to the full voltage, and this is the stop time. Also the time it will take for it to fall from the full voltage to our initial voltage and eventually off. So we have the input side, the power input side. This is this L1, L2, L3. Then underneath here we have the power output side, so which can now go into your normal direct online. So let's get started with this. Then you have the terminals. We have about 8 terminals here. We have the R1A, R1C, the common, the Li1, Li2, Li plus, the boost, and L01. Now this L1A and R1A and R1C, they are the normally open of an internal relay. Why this is a common? Why this L1 plus, it is a supply of 24 volts internally. An internal 24 volt is being generated, which comes out through this terminal. Whenever you connect a 24 volts to this L1 plus, rather the 24 volt comes out internally. So this 24 volts, the L12 must see it before the soft starter can start, and the soft starter is being started when Li1 sees the 24 volts. I will show you. You understand this in the schematic diagram. I said that the Li2 must see this 24 volts first before Li1 will see it for the soft starter to start. Whenever there is a disconnection between the Li2 and Li plus, the soft starter will stop. So you see the means of stopping the soft starter is just by disconnecting the Li2 from the Li plus. We have the boost. Sometimes we don't need this, and we have the L01. This is an indicator to show that it has attained its full voltage. So you can connect this to an indicator light or anything. Okay, so let's move ahead. So this is a normal direct online, which is being used to control this system. This is a common system in the industry, where you see a motor driving a pulley through a belt. It can be a conveyor, it can be in a gas station, it can be a fuel pump, it can be anything as long as the motor is driving it. So this is where we normally apply this soft starter. The reason is this control tends to generate high current when the motor is being started. Now look at this. We have the motor rated current to be 4 amps, and we have the motor starting current. It could go as high as 10 amps, and the overload is set at what? 4 amps. So it can't, because you want to accommodate this starting current, you now try to increase your overload. That will damage the motor, because the aim of the overload is to protect the motor. So you have to set the overload according to the motor rated current. So what normally happens is this: when you try to start this system with your direct online control, the overload will be tripping off. Because the starting current is above what you have set. So what do? Sometimes you adjust the overload to accommodate this, but that's not good. It will damage the motor. So you see, so that is why a soft starter is being needed. So if you have encountered this in the industry, and your own, the way you overcome it is by increasing the overload, don't do that. Use a soft starter. That is what will solve your problem. So you can see, when a soft starter has been applied, the motor starting current is now less than 2 amps. So you see, so it will gradually now rise and maintain at the running current, which will still not above the motor rated current. So let's see the connection of the soft starter to the direct online. So this is the inclusion of the soft starter to the direct online. So the soft starter has now been included. This is the power diagram. The control diagram will be in the next slide. So this is the power diagram. You can see the power comes in to the input of the soft starter and comes out at the output of the soft starter, and goes into the input of the contactor, comes out at the output of the contactor, goes in to the overload, and comes out of the overload and now go to the motor. So we can see how we will now see how we are going to control this, because you need to be controlled through push button, start button and stop button. So let's see how that is being achieved. So this is the schematics. You may not really understand this. Let's look at the practical schematic diagram. This is the practical schematic diagram. This is how it's being wired and applied and connected in real situation. So we have 4 buttons for controlling this. You can see we have a stop and the start button. This is for contactor. The first one is for the contactor. We have another one, the stop and the start button. This is for the soft starter. So you see, each of these components need to be started individually, separately, or if you can, synchronize the 2 start buttons, that will be better, because it's not usually advisable to start the soft starter without or before the contactor. So to avoid this, you synchronize the 2 start buttons. We have double pole start button, but these are single pole. But if you can't get the double pole, you can still use the single pole, just like I have used here. But make sure that you start the contactor before starting the soft starter, because if you start the soft starter, you have not achieved your aim. The motor needs to be connected to the soft starter immediately the soft starter is being started. So if you start the soft starter without starting the contactor, the motor has not been connected. So you end up, not achieving the full use of the soft starter. So let's look at how this is being connected. We have I told you this first start button is for stopping the contactor, and this one is for starting the contactor. This for stopping the soft starter, and this for starting the soft starter. So let's look at how it's being done. We have a single phase supply, the red cable. It goes to the normally close of the overload. We normally use the normally close of the overload because it shows that the overload has not tripped, that is working fine. But when the overload has tripped, the normally close of the overload will now become normally open. So, and it will no longer be continuous. But since it has not tripped, so the normally close is still active. So this signal comes out out of this brown cable, as you can see, comes out of the brown cable and goes to the input of the stop button of the contactor. Okay, then the output comes to the arrow IA. I told you the arrow 1A and arrow 1C are internally normally open of a relay inside the substarter. Okay, then you have the output also goes to the input, one of the inputs of the start button, so that whenever you press this, the contactor starts. So you can just watch how the connection is. And just watch how the connection is. You can watch the retaining contacts, you know how where it's coming from. It's coming from the RIC. If you have any question, you can ask me. If you have any question, ask me, I will answer you. So this is the stop button of the substarter. So you can see how it's being connected. I told you the L1 plus goes like this. I know a stop button is normally closed, so the L12 is seeing that 24 volts, so that whenever you press X2, that's the start button of the substarter, the substarter will start, provided that L12 is seeing the signal from L1 plus, Li plus. Li2 is seeing signal from Li plus. If you want to stop the substarter, you press this red button. That's discontinuing the 24 volt supply into that L12. The substarter will stop. And if you want to stop the contactor, you press this, the contactor will stop. So this is self-explanatory. Just follow the connection diagram. You get it. You get it. So stop increasing your overload whenever your motor is tripping up at startup. It's not the right thing to do. Some people use fuse, because a fuse, it can absorb that high current, but with time it will burn. So you keep on replacing your fuse. Is that what you'll be doing? The final solution is using what? A soft starter that will enable your motor to start at a very, very low voltage and low current. So in that way you have gotten over the challenge of starting with a high current. So like I said, if you have any question, you can ask me. It's self-explanatory. The video is so simple and it's so self-explanatory. So this is a Schneider soft starter. It's actually one of the best. I've used ABB, I've used Schneider. I think Schneider is simple in connection, so you can see how it is being done. So you can see even the potentiometer can be easily manipulated. Alright, so you can connect it and give me a feedback. Alright, thanks for watching.